Alright, here is my video guide for the review that is to prepare us for the assessment on Wednesday. Hopefully everybody finds some of these doable, and then the ones that they get stuck on, they're using this video as guidance. I've been saying I'm trying to make it shorter, so I'm just going to get right into it. The first problem on the review is saying if each, just one, when it says each, it just means one exterior angle on a regular polygon has a measure of 12 degrees. How many sides will that polygon have? And what we learned in class is that the exterior angles of a polygon, whether it's regular or non-regular, the exterior angles always add up. All the sum of them all always adds up to 360. And so we have to think is, if each of them is 12 degrees, how many sides would it take for that to get to 360? And the short way to do that is you say there's 360, we know there's 360 degrees total if you summed up all of them. And you can divide that by the 12 degrees, and this will tell me my number of sides. And so 360 divided by 12 tells me this is a 30-sided shape, so there's 30 sides. And to go with what I was saying, well, if each one is 12 and they have to add up, and if each one is 12 degrees, and there's 30 of them, that should mean that that goes to 360. And so you say that there's 30 sides, and each of them has 12 degrees, kind of working backwards here. 30 sides times 12 degrees each, that tells me that's a total of 360 degrees, and that is what we want to see for exterior angles, because we know the sum of all the exterior angles, has to go to 360, has to add up to 360. All right, on to the next one. What is the measure of just one interior angle of a regular decagon? And so a decagon, a 10-sided shape, and we're looking for just one interior angle, okay? If we're looking for just one interior angle, the equation we use for just one interior angle is n minus 2 times 180 divided by n. In this case, in the case where I'm using n is the number of sides. And so what I do here is I say this is a decagon, and so I'm plugging in 10 for my n, because decagon has 10 sides. So 10 minus 2 times 180 divided by 10. And then it's just working this out. 10 minus 2 is 8. 8 times 180, and the 10 on the bottom still stays. This is when I use my calculator here, and I'm just going to take a couple extra steps to show it. 8 times 180 gives me 1,440. I'm still doing this over 10 because I haven't divided yet. And then 1,440 divided by 10 gives me that just one interior angle is 144 degrees. Okay? Now, just as a quick reminder, this is the equation we use right here. This is the equation. I don't know why my thing's not working. This equation right here is the equation we use when we're finding just one interior angle. Okay? If it said find the sum of all the interior angles, if it said find the sum of all the interior angles of a decagon, the equation we would use instead of that one, we would just use the n minus 2 times 180. That's the equation for the sum of all the interiors, of all interior angles. Okay? But for this problem, we just wanted to find one, so this is the equation we used, and we come up with 144 degrees. All right? In this polygon to the right, we want to find what the value of x is. This is one that I put on a formative at one point. And the idea here is we need to know what the sum of all the interior angles is. And then we're going to set, we're going to add all these different ones up like the x's, and we're going to set it equal to that sum. Well, this is a 1, 2, 3, 4, 5-sided shape. And so to find the sum of all the interiors of a 5-sided shape, we use the equation I just talked about in the last problem, the sum of them all, and that is n minus 2 times 180. This is a 5-sided shape, and so I plug in 5 for my n, my number of sides, and I get 5 minus 2 times 180, which goes to be 5 minus 2 is 3 times 180. And 3 times 180 gives me that there's 540 degrees in this polygon here, in this pentagon here. Okay? The next thing I'm going to do is I'm going to figure out what this interior angle is right here. All right? Well, if the exterior is 83, I know that interior plus exterior is supplementary. It creates 180 degrees. So to find this missing angle, what I'm going to do is I'm going to take 180 and I'm going to subtract away 83. And whatever is left is going to be my interior angle because those two are supplementary. So 180 minus 83. This is a 97 degree angle in here. Okay? Now what I'm going to do is I'm going to take all my interior angles and I'm going to add them up and I'm going to set them equal to 540 because I know that's what they have to equal. And so what I get is I get x plus 14. That's one of my interior angles. Sorry. X plus 14 plus 97 plus x plus 90 from that 90 degree angle plus another x, and that whole thing needs to equal 540. The sum of all those needs to equal 540. And then I start combining my like terms here, so I combined all my x's and all my non-x's. So I have an x, another x, and another x. They're all being added. So x plus x plus x, that gives me 3x. And I'm going to put it in red, I have 14, 97, and 90. I need to add all those up. So 14 plus 97 plus 90, that gives me plus, I'm going to go back to using black here. 3x plus 201 equals 540. And now I just have an algebraic equation in which I need to solve for x. And so first thing I'm going to do, I'm going to subtract away 201 from both sides so that goes away, and I'm left with 3x, and then 540 minus 201 is 339. Then I need to divide both sides by 3 because then my 3's on the left side cancel out, and I just get that x equals 339 divided by 3, which gives me 113 is my x. Okay, so really what I did there, the first part right here, I did my equation to find the sum of all the interior angles. Then I added up all my interior angles, even though they have variables in them and they have different things in them. I added up all of my interior angles right here, and I set it equal to 540 because I know that's what it has to equal from my formula. And then I combined my like terms and solved for x, which gave me x equaling 113 degrees. All right, going on to number 4. We are finding the area of a regular octagon, and we know that this outside is 10 centimeters. Every side is 10 centimeters. It's a regular octagon, and this is just one where we follow our steps. The first thing I always said to do was turn this into a triangle. All right, and then once we see our one triangle, our idea here is we find the area of that one triangle, and we multiply it by the number of sides. This is an octagon, so at the end we'll multiply that area by 8. All right, but we look at that first triangle and we say, well, what's that central angle right here? And to find central angle, we do 360 degrees divided by our number of sides. This is an octagon, so it's got 8 sides, and then we do 360 divided by 8, which gives us, that's 45 degrees. So my central angle is 45. Then I drop my apothem. Here, creating 2 right triangles, but that apothem cuts the bottom. And I'm just going to redraw that quick now. And so I have this big triangle now. The apothem is cutting it. So now it cuts the side length that was 10, so now this is 5 and this is 5. I had that whole central angle of 45, but that got cut in half. So now 45 divided by 2 gives me that this angle right here is 22.5 degrees. Okay? This one's really not too bad because we actually have a base already. We know our base is 10, and we just need to find our height here, which I'm going to call y. Well, what I have is if 22.5 is my angle, 5 is opposite, and y is adjacent. Y is the adjacent because my angle is right here and my 90 is right here, and my y falls between my angle and my 90. And so if I have opposite and adjacent, this is a tangent problem. So if I want to find y, what I do is the tangent of 22.5 degrees equals my opposite, which is 5, over my adjacent, which is y. I put tangent of, I do this where I've done this before, I put this over 1 and I cross multiply. 1 times 5, tangent of 22.5 times y. So my next step should look like tangent 22.5 times y equals 1 times 5, which is 5. I then have to divide both sides by the tangent so it goes away. Tangent of 22.5. And the same thing divided over here. I'm just going to put tan because I'm going to run out of room. So my tangent cancels, and what I end up getting is y equals, and I need my calculator for this, y equals 5 divided by the tangent of 22.5, and that gives me a height of 12.07 centimeters. All right, and that one, again, like I said, is kind of nice because that's the only trigonometry we have to do. Now we have this base, which is 10. We have a height, which is 12.07 centimeters, and we can use my equation to find the area of this one triangle. And area of a triangle, so area of one triangle is 1/2 base times height. I said my base was 10 and my height was 12.07. When I calculate this out, I get an area of, well, 1/2 times 10 is 5, so 5 times 12.07. I get an area of 60.35 centimeters squared. Now that's just the area. That's the area of this triangle. This is an octagon, which is made up of 8 of those triangles. And so I take my area here. And I multiply it by 8. And I'll get my final answer. 60.35 times 8 gives me a total area of 482.8 centimeters squared. Okay. Again, this is on the 3 different types of problems they can give you. This is really not one of the harder ones because all we needed to do was trigonometry to find y, and then we used that as our height and used our equation to find the area of one triangle. Said it was an octagon, so we multiplied it by 8 and found our total area. The things that might screw people up on these, again, is just realizing we turn this into a triangle. We find that central angle. The apothem splits that central angle and it splits that side length. And then we need to make sure that we have a base and a height. And then we're able to solve for area of one triangle, which then can help us solve the area of all the triangles. I'm going to stop this video here, and I will be able to finish up the rest of them in a second video.